Hi everyone, welcome back. How are you all? Today we are going to study projectile motion. Projectile, what is projectile motion? Many times we have thrown a ball into air. How do we throw a ball? We just directly throw upward like this. The ball goes and then it comes down. Similarly, sometimes we throw a ball at an angle with horizontal. So how the ball will move? The ball will move in this path. This path is known as parabolic path. Okay? So let us assume some terms. What are the terms given here? U is the velocity of projection. Theta is the angle of projection, which is the angle made with horizontal. So use the velocity of projection. Velocity of projection. Theta is what? Angle of projection. It is the angle made with vertical. Okay. So we need to find out the time of flight. What is the time of flight? Time of flight is the time it takes to go from A to C via B. This topmost point is B. How much time it will take from A to C, going from A to C. Okay, so this is known as time of flight. We will find the time of flight here in this video. We will find out time of flight. Time of flight is the time for which the particle remains in air. Okay, so before starting, we need to understand some basic terms. What are the basic terms here? First of all, when the particle is in air, or there will be only one force, and that force is gravitational force. The particle will be in free fall state. What does it mean? When there is only one force, that is gravitational force, we call it the particle is in free fall state. Free fall. Okay. So the particle is in free fall state. There is only one single force that is acting towards, which is gravitational force. It implies that there is only one acceleration, which is in the downward direction. So acceleration here is in downward direction, and what is that? This is equals to G. Value of G is 9.8 meter per second square. 9.8 meter per second square. Okay, let us try to understand something. See, the motion of the particle will be like this. When the particle will be here, let us assume the particle is here. The particle is here. Let us assume the particle is here, and we try to project light from topmost point. From topmost point we try to send light. We are sending light from top. So what we are doing, we are sending light. Let us assume this green color are light. These green colors are light. Okay, these green colors are light. So what will happen? These light will come here, this light will come here, but what about the light which is passing through this? The light will not pass, so there will be a shadow. The particle is here, but its shadow is, the particle is here, but its shadow is here. Now think, how the particle is moving? The particle is moving here in air. How the shadow will move? Now think like this. When the particle will be at topmost point here, its shadow will be here. When the particle is here, its shadow will be here. So the shadow will move along this line, and the particle will move in parabolic path. Movement of shadow is one-dimensional motion, and movement of particle is two-dimensional motion. Similarly, if we send light in leftward direction like this, what will happen? We will get a shadow in y-axis. How the shadow will move? The shadow will move in this way. When the particle is at bottommost, the shadow will be here. Then the shadow will start rising, right? When the particle is at topmost point, the shadow will be here, then it will start falling. Why the shadow will start falling? Because the particle, when the particle is here, its shadow will be here. So the motion of shadow on y-axis will be, the shadow will move up and the shadow will move down. Okay, this is the motion of the shadow in x-axis, in y-axis. Okay, so we are trying to find the time of flight. So now consider the motion in y-axis. The motion of whom? The motion of shadow. The motion of shadow, like this, in y-axis. So first of all, try to break this velocity. This velocity is u and this angle is theta. So we have this component u cos theta from vector and u sin theta from, we know by using the components of vector we get u cos theta and u sin theta. So initial velocity in the vertical direction will be u sin theta. So initial velocity in the vertical direction is what? U sin theta. See, when the particle will start from A and finally will reach to C, when the particle will start from A, its shadow will be here. When the particle will be at B, its shadow will be at topmost point. When the particle will come to C, the shadow will come back to its original position here. So how do we find time of flight? We use equation of motion. Second equation of motion, S is equals to ut plus half at square. Right, this is the second equation of motion, and we are using in y direction. We are using in y direction. So displacement of the shadow, what will be the displacement of the shadow? The shadow is moving up, now it is coming, thereafter it is coming down to its original position. So then the displacement of the shadow will be 0. Initial velocity of the shadow in y direction, which is u sin theta, u sin theta, this is the initial velocity in y direction, into t plus half acceleration. What is the acceleration in y direction? We have seen acceleration in y direction is 9.8 meter per second downward, in the downward direction. So it will be equals to minus g. Why I have written minus? Because we follow Cartesian coordinate system. What is that Cartesian coordinate system? We follow this system. Anything in the positive x-axis will be taken as positive, anything rightward in the rightward direction will be considered as positive, anything in the upward direction will be considered as positive, rest will be negative. So here acceleration is in downward direction, that's why I have taken minus g, else I would have taken plus g if it would be in upper direction. Okay, see here also I have taken u sin theta, not minus u sin theta, because initial velocity is in upward direction. Okay, minus g into t square. From here, see this is in this is a negative term, minus half gt square I am taking here, so it will become half gt square is equals to u sin theta into time taken. From here you can say, you can cancel t and t, what will get? T and t is cancelled. Here from here you get t is equals to 2u sin theta by g. This is the time of flight. This is what? This is the time of flight, or you can say time for which the particle remains in air. Okay, I hope you guys have understood. Okay, thank you.